Yes, now student, the next content is distinction between 1 degree, 2 degree and 3 degree alcohols. Student, whenever you are asked the question regarding it, how do we distinguish or how do we distinct? So the only way is to perform a chemical reaction of the same compound, okay, with same chemical reagent with different type of compounds given, like 1 degree, 2 degree and 3 degree alcohols. Okay, remember, on the basis of structure, that in the primary alcohol, in the secondary alcohol and in the tertiary alcohol, 1 alkyl radical, 2 alkyl radical and 3 alkyl radicals are directly attached. No, not on the basis of this, on the basis of chemical reaction performed with the same chemical species, and then we will observe whether the different type of substances are formed and what are the characteristics of that different substance with shows difference with other compounds. So in this way we have to distinguish. So the first distinguish test we can select is distinguish by using Lucas reagent. Student, in the first chapter we have seen the reaction of different alcohols with Lucas reagent and formation of different type of products with different properties. What is the Lucas reagent? It is mixture of ZnCl2, that is zinc chloride, which act as dehydrating agent, plus HCl, that is hydrohaloic acid. This is called Lucas reagent. So it is mixture of ZnCl2 plus HCl. When the Lucas reagent is reacted with different type of alcohols, like what? 1 degree, 2 degree and 3 degree. Then white PPT, which we are calling turbidity of haloalkane is formed. Haloalkane is formed. Okay, haloalkane is formed, but time, this is the most important thing, but time taken for reaction is different. Okay, like number A, tertiary alcohol, okay, forms turbidity, okay, very fast. That is what? Within 5 minutes. That is very fast. That is, as soon as you will add tertiary alcohol and Lucas reagent, you will find that the turbidity is getting formed very fast. Number B, secondary alcohol forms turbidity after 5 minutes. So here the time is important. And number C, 1 degree alcohol, okay, is least reactive. Is least reactive. Okay, so take 20 to 25 minutes. So on the basis of time, we can distinguish which one is primary alcohol, which one is secondary alcohol, and which one is tertiary alcohol. So this is one of the chemical test through which we can distinguish primary, secondary and tertiary alcohol. Student, one more test is there. This is called iodoform test. Iodoform test, or this is also known as haloform test. Haloform test. Actually, the basic thing is what? Haloform. But I am explaining by using the formation of iodoform. Therefore, I am saying it what? Iodoform test. Student, this is very important chemical test, and it is applied in the next chapter, aldehyde ketones. Okay, and to distinguish aldehyde ketones also. But here we are distinguishing 1 degree, 2 degree and 3 degree alcohol. Isn't it? So, now haloform test. Very first, what is haloform test? So, formation of haloform. How the formation of haloform takes place? When sodium hydroxide, okay, iodine, okay, and carbonyl compounds having methyl carbonyl group is added, then haloform is formed. I told you this time I will call it what? Iodoform. This is yellow color PPT. This is called what? Iodoform. Student, the most important thing is what? The haloform reaction is only given by carbonyl compound, and this carbonyl compound must have methyl carbonyl group. That is, in the given carbonyl compound there must be CH3 directly attached with CO, like that. CH3 must be directly attached with CO, and here there may be any other thing. Okay, this is called methyl carbonyl. Okay, how the reaction takes place? When sodium hydroxide reacted with iodine, first it forms NaI plus NaOI. This is called sodium hypohalite. And then in the next reaction, when NaOI, that is sodium hypohalite, is reacted with RCO, okay, and there must be, I told you what? CH3. Okay, then with this reaction it forms CH and what? I3. This is called iodoform. And obviously some few new products also form, like RCOONA. But the most important thing is what? The formation of yellow PPT of iodoform takes place. This reaction is known as iodoform or haloform reaction. Now, using this one, how will we distinguish 1 degree, 2 degree and 3 degree alcohol? So now, what is 1 degree alcohol? 1 degree alcohol is 1 degree alcohol. Okay, what is it? This is CH3. CH2 and OH, isn't it? When this alcohol is oxidized, it converts into what? CH3. This is CH3. C double bond O and H means what? Ethanol. And the ethanol is having what? Methyl group with what? Carbonyl group. So methyl and carbonyl group are present. That means this will form iodoform. So what we can say? Primary alcohol. Okay. If we are selecting ethyl alcohol, whenever it will form this one, means only ethyl alcohol can give this reaction. Okay. What about propanol? If you write propanol, this is CH3CH2. Okay. Again CH2 and OH. This is what? Propanol. If you oxidize propanol, now it will form what? Propanol. CH3, CH2, C double bond O and H. Here, this is a carbonyl group, but this carbonyl group is attached with CH2, not attached with CH3. That means what? It will not give what? Iodoform test. So in this way you can distinguish it. How will you distinguish primary and secondary? Okay, alcohol. Like primary alcohol is CH3, okay, CH2OH. But the secondary alcohol is what? Secondary alcohol is C. This is CH3. This is again CH3. This is OH and this is what? H. This is secondary alcohol. So when the secondary alcohol is oxidized, okay, the secondary alcohol will form CH3, C. Again there is what? CH3 and C double bond O. Means what? With the C double bond O, directly CH3 group is linked there. That means it will again give iodoform test. Either is it clear? Means what? 1, 2, 3. Propane to all can easily gives what? Iodoform test. Okay, but not propane 1 all. Look at propane 1 all will not give iodoform test. Iodoform. Okay, while what? Propane to all can give. Okay, similarly we can see methanol cannot give. Methanol cannot give iodoform test. Iodoform. Okay, but ethanol can give. Ethanol can give what? Iodoform test. Iodoform test. Isn't it? Why? It is because when we are using methanol. Now what is methanol? This is CH3 and OH. So if we oxidize it, so on oxidation it will form H, C double bond OH. That means what? That means there is carbonyl group, but there is no CH3 group. Okay, that is no CH3. Therefore it will not give iodoform test. But the ethanol, like here ethanol, okay, ethanol can easily form what? Ethanol, that is acetaldehyde, and acetaldehyde gives iodoform test. So in this way we can distinguish what? Primary and secondary alcohols, or methanol, ethanol and propanol. So between methanol, ethanol and propane 1 all, only ethanol can give test. Methanol and propane 1 all cannot, but propane 2 all can give the iodoform test. Okay. Yes, student. Now the next one is phenols. What are phenols? Okay, these are also similar to alcohols. That is what? Having OH group. This is the similarities, that is containing OH group, but the other thing is different. That is called what? Phenol. What is it? When OH functional group is directly attached with benzene ring, okay, such compounds are called phenol. Such compounds are called phenol. Okay. Actually, some more thing is there. Even if benzene ring and hydroxy group, between these alkyl radical is also there. Whenever they are considered as the category of phenols. Okay. Now the next one is classification on the basis of numbers of OH group. Numbers of OH group. It may be monohydric. Monohydric means what? One OH. Dihydric, that is what? Two OH. And trihydric means what? Three OH groups are directly attached with the benzene ring. Such compounds are called phenols. So monohydric phenols, dihydric phenols and trihydric phenols. Let's search first one, monohydric phenols. Okay, means only one OH group attach with benzene ring. Now, how it is? Like this is what? One OH group is directly attached. Okay, this is monohydric. Okay. If we see some substituent again containing only one OH group, but along with there is CH3, okay, in second number carbon atom, then this compound is called orthocresol. Okay. Ortho why? Because the position of methyl group is in ortho position, therefore called orthocresol. Again the benzene ring, and with it directly attached only one OH group, but now the position of CH3 is here. This position is called meta, therefore this is called meta, but the main thing is what? Cresol. And one more compound is possible. What? With benzene ring directly attach what? OH, but now the position of CH3 is here. So this position is called para. So this is called para, and main compound is cresol. Getting? So phenol, this one is simply phenol. This is called orthocresol, means type of phenol. This is metacresol. This is what? Paracresol. And all these are having only one OH group. Therefore, this is called monohydric. Now, dihydric phenols. Dihydric phenols means what? Two OH group directly attach with benzene ring. Okay. Now there will be what? Two OH group, like here one OH attached here and the second OH attached here, isn't it? So two OH are directly attached. Their position may be changed. Like again, if I can draw, here is OH and again one OH is here, and one more possibility is there. What? Benzene ring. First OH is here and the second OH is here. So all these alcohols have what? Two OH group, called dihydric phenols. Like here, you can call this phenol 1,2-benzene diol. What? 1,2-benzene diol, or you can call it what? Benzene 1, 2. That is position. This is first. This is second. Diol. Okay. I am writing here what? Diol. Diol. Why? Because OH group is named what? Ol. So diol. This is also termed as catechol. Catechol. In short, commercial name is catechol. Here you can call it what? Benzene. Now 1 and what? 3. And again 2, therefore di, and functional group is OH, therefore all. Okay. This compound is known as resorcinol. Resorcinol. Okay. And the third compound, this compound, you can see here. Now what is this? This is benzene. Now position is first position, therefore 1, and fourth position, therefore 4. How it is? 1, 2, 3, 4. So 1, 4 and 2, therefore di, and OH functional group, therefore all. Diol. This compound is very important compound. This is called paraquinol. Why paraquinol? Paraquinol because this position is termed as para, and the compound becomes what? Quinol. Like catechol, resorcinol and quinol. This is also known as hydroquinone. Hydroquinone. Okay, in advanced chemistry, you have to study about it. Hydroquinone. Okay, so this is secondary. One more is trihydric alcohol. Phenols. Trihydric phenols. Now, what are trihydric phenols? So, if how many? 3 OH group is directly attached. Okay. Now, 3 OH group, their position may be changed in the benzene ring carbons. Okay. And therefore, their property will also getting changed. Like here, you can see first compound. Okay. Here, the position is OH. Position is one more OH, and position is of OH is in third. So first, second, third. So that become what? Benzene 1, 2, 3 and triol. Simply, you can name it what? Benzene, because benzene ring is there, and 1, 2, 3 and 3, therefore tri, and OH group, therefore triol. So benzene 1, 2, 3 triol. Similarly, you can draw some more compounds like benzene ring. Now put there one of the OH, one more OH, And now the third OH is in fourth number carbon atom. So that will become benzene 1, 2, 4 triol. One more compound is possible. What? The position of OH in carbon is changed. So first, okay, this is third and this is what? Fifth number. So benzene 1,3,5 triol. Okay, so in this way we can study about phenols and its classification.